So now I'd like to introduce our next speaker for the morning, Yasmin Kafai. Yasmin is a professor of learning sciences at the University of Pennsylvania. She's a researcher and a developer of tools, communities, and materials to promote computational participation, crafting, creativity. She's the author of several books, including Connected Gaming, what making video games can teach us about learning and literacy, which Dan read a little bit about this morning. She's also written Connected Code, Why Children Need to Learn Programming, and one that I really want to read, Beyond Barbie and Mortal Kombat, New Perspectives on Gender in Gaming. So I first heard about Yasmin's work maybe about 18 months or 2 years ago. I saw a tiny little article in one of the American education research journals that we get at NZCER or a magazine. And I think maybe somebody had seen the article and they'd written a little note to me to check out, page so-and-so. People knew that I was interested in game stuff. And at the time, I think Yasmin and Quinn Burke were still writing their book, Connected Gaming, and perhaps they'd been presenting at AERA, which is a very big education research conference. And so it's just a tiny little story about it. And I think this was the first time I'd come across the phrase constructionist gaming. And so I immediately got online. I wanted to find out more. So when that Connected Gaming book was published, I think it was early this year, I'm pretty sure I was the first person in New Zealand to get a copy shipped in. And within, a few chapters of reading it, I was like, need to find this woman's email address, need to get her over to New Zealand for our conference. And amazingly, like the other international speakers that we've reached out to and our national speakers, she said yes. And she's managed to fit in this trip in her very, very busy schedule this year. And she's come a very long way. So Yasmin, I hope that you are starting to recover from that journey, and I'm really looking forward to your talk. Welcome.
Whoops. Thank you very much for this invitation. I want to say guten Abend, good evening, because for me, I'm in a different time zone, but I'm holding up. My name is Yasmin Kafai. I'm Iranian born in Germany who now lives for nearly 30 years in the United States. And what I want to talk about is connected gaming. And I like to give the outcome of the talk away. I guess if this would work. And the point I want to make today is that we have created the separation between playing and making games. But what I want to push forward in the future as we think about making gaming part of learning, that we really should look at these two things as two sides of the coin, and not just doing playing games for learning or making games for learning, but figure out on how we can pull in the best pieces in whichever context we are. So this is the whole talk. I can finish now and go back to bed, but don't worry, I'll give you a little bit more on how this all works out. So Brown-Stuckley yesterday did a really wonderful job talking about gameful experiences, because it is already a broader kind of conceptualization on how we should think about games and learning. Unfortunately, I think for the last 15 years or so, most people think when they hear games and learning about playing games for learning. And don't get me wrong, I mean, we had examples yesterday. People have designed wonderful games for learning. A lot of this started with Jim G's book, What Video Games Can Teach Us About Learning and Literacy. And connected gaming is actually a conversation with this book, kind of taking the ideas which Jim Paul G promoted in 2003 to the next level, to be more inclusive of making games for learning. So what I want to do today, I mean, we have plenty of examples of those what I call the instructionists, the games that teach learners, whether it's from America's Army, for math, for science, for all kinds of topic areas. But my advisor, Seymour Papert, who just passed away recently at MIT, made already over 20 years ago a very astute observation when we started looking at games and learning, and he said people are fascinated by the energy which kids display learning how to play video games. But he says it's very interesting, and in the education sector, you know, most of the people try to think when they see this energy about kind of creating games for learning that teach. But I think there's another perspective, which he called the constructionist perspective, when we actually have the kids design their own games for learning and playing. And so this idea of constructionists making games for learning has taken actually root on its own. There are tons of tools out there. You learned about a few yesterday. There's many more. There is Scratch, which I helped to co-develop with Mitchell Resnick at MIT, Tinker, Code Combat, you name it. And all of this started over 25 years ago when I was at the MIT Media Lab, and Nintendo, believe it or not, gave us actually $1 million, which was a lot of money, and they got more worth of publicity for that money. And everybody believed we would design the perfect educational game. But we actually did something very different. At the time, we had an experimental school site called Project Headlight, where hundreds of computers were in an inner city elementary school. You cannot imagine how revolutionary this was, that little dirty fingers would touch these expensive machines. By the way, these were 256K machines, and as you can see from the logo, IBM was still in the business of producing hardware, which they don't do anymore. And so what we decided to do is to turn the tables and actually to ask the children to make a game to teach fractions to younger students in their school. And I still show this video. I hope this will work now.
It's demo time for parents at the Hennigan School in Boston.
He will ask you a fraction problem. If you get it wrong, you will become mentally deformed.
After months of work, the 5th grade students are showing off the computer games they created. Even the principal is here to take a try. The children are using the programming language Logo, invented by this man, Seymour Papert. As part of a bold MIT Media Lab experiment known as Project Headlight, Papert, his research team, and the Hennigan teachers are developing methods to put inner-city children in charge of their own learning. Instead of using purchased software like most schools, Project Headlight challenges the students to use Logo to create their own software.
How did you decide what to put in your messages when you get it right? Well, they're basically all the same. I don't know. I just thought it'd be encourage them if it was right.
What do you say when they're wrong?
That's wrong, try again.
Yeah. In the design process, they become expert programmers. They draw, manipulate shapes, even guide a skier down the slope. And like all the students, this one is built in a surprise. When the skier hits a bald spot, a fraction quiz. No run-of-the-mill video games. These are designed to teach mathematics. Abigail has chosen to design her fraction game around the Greek myths.
You want to go to the home of Zeus, but the map was ripped up by the Greek god Hades. All the Greek gods and goddesses have a fraction in the map. You're to go to the gods and goddesses one at a time.
Her toughest challenge involves allowing the user to choose an answer from the quiz. She's had to learn the hows and whys of the ifs and thens.
The hardest thing about this is making the program for what your answer is to the fraction problem. Right? If you push A, then you do this, and then if you push B, then this happens, and C, then this other thing happens. So it's really hard.
The fact that a 9-year-old is learning such sophisticated programming concepts is a testament to Project Headlight's success. And for Abigail, the command of the computer allows her to devote her attention to what she really enjoys. Designing a Nintendo-style interface and creating a compelling story around the gods. Ginny has designed her fraction game around a spider web. Like her classmates, she's learned advanced programming. She's also learned the advantage of producing her own game.
Because you make your own game and you can play it anytime you want. But in Nintendo, this right here, you don't have to buy it because you're the one who's making it.
With Nintendo as a model, she's even designed her own game box.
Like, at first I didn't know how to design a web. And so the art teacher helped me and I designed it.
In fact, as part of the project, all of the children package their games and promote them with an ad campaign. These integral activities make this project unlike any textbook exercise. The students here are designing a real product from start to finish. And through the process, they learn about every advertising medium. They even produce TV commercials.
If you play this game, play it good, you may grow up to be like Ronald Reagan. Wow. Town is awesome. It's spooky, it's scary, and it's exciting. And it's by TCA. Awesome.
So I still show this today because, you know, this was done on very simple machines. I mean, compared to the smartphones you have in your pocket today, who have 100 times more the computational power. But it was also a curricular project. It wasn't something where kids would go once a week for 45 minutes. It was part of the daily curriculum. Again, that was very unusual over 25 years ago to have daily access to computers. But it was also part of the mathematics class, because this was about fractions, the very topics these students were actually learning about at the same time. And they were tasked to design a game that would teach younger students, just a grade younger, who, by the way, would come in once or twice to evaluate the software and progress. We wanted to instill good software design practices and provide feedback to the designers. This doesn't work. And so the idea behind this, rather to have the computing, the learning program separate, we were integrating it with content to be learned, so it became part. And we used what we call instructional design, the idea that you can learn actually by explaining things. And as you could see from the examples, this didn't just take place in the computer class or math class. The language arts class was involved with kind of creating advertisement, which is a big topic of fourth grade instruction in the United States. And there was also the art class involved. Those were the days when games still came in boxes, and actually very intricate boxes. So the students were recreating all of this. And I use this as an example to show how the learning of computing and games could actually become part of the curriculum rather than to be separate. And this is an important topic area nowadays when we think about constructionist gaming. So a few years ago, I actually went back and looked what happened since this first game design project, which was, you know, in the early 1990s. And I conducted what was called a meta-synthesis. And for those of you who are interested in the details and findings, you can actually, it's an open access article, you can kind of get that from the thing. But I started to look, do kids actually learn from these things? And so what I found from the 55 studies which were included into synthesis, over 9,000 students participated in this study, so this is definitely a significant number. And these were studies not just conducted in the United States, but all over the world, in Europe, Asia, and other places. And to my great surprise, many of those took actually place in school classrooms. I always thought this stuff kind of happened just in after school or online. Online, actually, in most of the studies, was a fairly small sliver. What I was particularly interested in the question, what do you actually learn when you make a game? So what I ended up doing to kind of put all these pieces together, I classified them into kind of more typical computer science, the coding stuff, the kind of key concepts, practices, and how kids thought about computing. But then I also looked at the content. What kind of social studies, language arts, STEM topics were kind of integrated. And then I realized that a lot of studies also looked at learning strategies, problem solving, and motivation. And here's what I found. When you looked over those studies where over 9,000 students participated, a great deal obviously focused on coding. But there was, about 1/3 of the studies, 1/4, which also had coding. And by the way, some of these studies actually had multiple goals. They didn't just focus on one. And another, fourth about focused on those metacognition. What was very few part, to my surprise, was kind of the collaborative aspect. And this might be just, a situation of the software and tools which make collaboration, collaborative design actually much harder than it should be. And this meta-synthesis, which looked over 20 years what people have done, gave us some indication that making games for learning can actually be a rich learning activity. And I'm doing this because right now, as you heard from previous speakers already, there's a big talk in 21st century learning, not just to look at the 4 R's, the reading, writing, arithmetic, and arts, but also to introduce coding. And one big way this is being discussed is under the umbrella of computational thinking. Who has heard about that word, computational thinking? Good. So this is a term which actually Seymour Papert coined in 1998, but then nobody was interested in programming in schools. But Jeanette Wing in 2006 wrote a little piece in a professional journal for computer scientists when they were feeling kind of down and said, but computer scientists have something special to offer. They can do computational thinking. You solve problems, design systems, and understand human behavior. And this is not just true for computer science, it really permeates all the different domains. And I think for games, this really applies very nicely because games are systems which are played and made, and they involve, when you play, solving problems. When you design system, and you have to understand human behavior in order to design a good game and to play a good game. And I think this fits right. For that reason, thinking about making games as a way to introduce digital literacy is actually a very powerful way. But often when we talk about literacy, we talk about the first part, adaptation, about the functional thing. You need to learn X, Y, and Z in order to be functionally literate. But I think there are 2 other aspects which we often forget. The second one is literacy as power. It's a political thing. The reason why we educate children is because we want them to be competent citizens to participate in society. And then there is a third piece, literacy as grace. The term is not from me, that is from Sylvia Scribner, a very old and well-respected literacy scholar. She didn't even talk about computers. And this is about the personal aspect. You learned to write in order to write a love letter to somebody. Okay, today kids don't write love letters anymore. They compose a compelling 140-character tweet. And that is a skill too. But we often, when we talk about digital literacy, we only talk about the first part, and we keep in mind that, yes, there is a larger reason, the political participation, but the personal is as important, and I would argue for most of the kids and youth today, this is how they connect and interface with technology. They do it through personal and social aspects. So when we think about coding, why making games, which is a good way to kind of introduce coding, we definitely can have a discussion on what kids should learn in terms of coding. And I'm not making by any way a case that everybody should become a computer scientist and engineer. I'm actually not interested in this. It is like when we teach mathematics or writing, we don't expect all children to become mathematicians or writing the great novel. We expect to have some functional literacy to be able to work in that space. But we also always should keep in power the political part. And with everything becoming digital today, we need to realize there is a political agenda on how those algorithms are written, who creates these interfaces, on how inclusive technology is. We cannot ignore this. And finally, the personal level. Coding isn't just about the technical aspect. It also is about personal expression in this particular medium. And that's why I actually think that computational participation rather than computational thinking is a much better way that leads us away to look at coding as just this kind of mind stuff, but really to understand that it's part of our social fabric in the digital publics in which we all, no matter which age, gender, SES, operate. And so what I want to kind of give you a flavor, making games has been extremely successful. I mean, there is tons of tools available for you to do this, but I've kind of come a little bit disillusioned on all the games I made because a lot of them just happen to be on the screen, and I'm thankful with Tara's talk to see some of the makey stuff that actually game design, as it also happens in the professional commercial context, can move beyond the screen. So we can think about designs where kids not just create games on the screen, but also create interfaces, create variable controllers, touchpad controllers, augment board games. There's a whole rich array of activities when you think about making games. Don't be stuck to the screen. Think about the world around it. And you showed examples of VR, kind of the latest technology, kind of interface technology entering the arena. So for those of you who are interested in practical aspects, I created a guide which has a magic F word, as Brown calls it. It's free. You can download this from my website, and it tells you what the materials are, what computational practices and concepts are embedded in the activity, and how to kind of set this up in your classroom, how long this took. And there's tons of papers where we've worked with teachers of doing this whole array of different activities to show that game design can move beyond the screen. And if you want to kind of take it a step further, say this is not funky enough, I've started 10 years ago working with what's called electronic textiles, making wearables, working with the Lillipad Arduino, which has been customized for sewing, where you stitch circuits with conductive thread. We have actually also ran hackathons in order to expand computing, where college students created new controllers for Huckybird. Another aspect which is very interesting, I talked about Scratch, which is one of the communities I helped co-create. And I started to being curious. You know, there's about, I think, 20 million projects, over 1 million participants. It's a global phenomenon. It has been translated, the language, into 40 different languages. And with Gabriela Riches, I started looking who is actually participating, what is the content there. And it's probably not surprising, yes, you have 1 million projects, but these projects tend to fall into very predictable categories. So Halo, very popular game. When you just, Google it within Scratch, you get over 26,000 projects. Now, if you type in anything about indigenous content, you get a measly 29 projects. And I looked at some of the comments where somebody wrote, oh, my teacher made me put up this project, so I knew this was not a labor of love which was posted. And I think this is something important for you to consider. You hear, as well as Games for Change and many other examples which Brown gave, there are many fantastic other games out there which could provide the foundation and the starting point for kids to make games. Yes, the commercial games are an important connecting point because kids play them, they're part of their communities, but it's equally important to broaden on what is being made and the kind of conversations around the games take place. Otherwise, we're just perpetuating the inequities we have already, and the stereotyping, which is so prevalent in the game playing community. And this is why very recently we put together a next edition on diversifying Barbie and Mortal Kombat, which is, if you are satisfied with the digital copy, is also freely downloadable. So, and where you can examine on how people actually think to create more inclusive game playing and design communities. And then finally, another way to look at this is to also not just broaden the design and content, also the context. We can also think about mobile gaming, actually, which happens in real space. And one of the tools, ARIS, allows you to become actually a game designer of mobile locative games. And we're currently working with an indigenous community in Arizona in creating maker stories where kids create visiting kind of local artists in their communities and create guided tours. I can't show you more because this is a question I asked yesterday. What are the negotiations? We're not allowed to show some of the content. But it was a great example on how a gaming platform can kind of be expanded to include culturally relevant content and help the kids also to better understand and connect with the makers in their communities. So playing and making games for learning, again, shouldn't be something which is just on the one side or the other. I think actually the examples we heard yesterday from Minecraft, to me already illustrate that making and playing can exist in one context where you have a creative and play mode and you can suavely move back and forth between both. Why should there be a separation? Mimi Ito actually wrote, when she looked at Minecraft, she looked at it more as a programming environment where the kids can kind of create their own world. But then importantly, they're not only making, they're also playing in them. And that for me is really the part where I can think about some actual recommendations for people who are interested in having kids play games. So think about how you can extend the playing by including game modding elements. I mean, for Christ's sake, all commercial games have modding features, whether it's character, level characters, all of those pieces. Engage players in metagamings. Each game has a great community, discussion forums, and cheat sites, which, by the way, are my favorite. Every time when I have to learn a new things, I could Google cheat and the name of the game because I know somebody else already figured out all the hard parts. And kids, I mean, down to Club Penguin, actually have created hundreds, if not thousands, of cheat sites and walkthroughs. And I think it actually speaks to the quality of an instructional games, whether the cheats are great. You know, if you have an instructional games where it's just about giving answers yes or no, there's not much to do in terms of cheat site development. But if you have games which require complex thinking and answers, then the cheats equally also have to be thoughtful. And again, there's also this idea of Minecraft micro as well. And I think likewise for my colleagues who are interested in using game design, I think we can learn something from the game players. I think we want to not just make games, we also want to make sure they're played. The one interesting thing about Scratch is it's not just a programming tool, it's also a community. And this is what makes it really compelling, that you have these people comment, provide feedback, help out. And I think that is an important, the performative part is an important part. Likewise, I think collaboration is equally important. I was very surprised in my synthesis to see how few collaboration there was. And I know in the first generation of Scratch, it was very hard to collaborate. I mean, kids had to kind of jump through all hoops, but the new version actually has features which make it easy for kids to collaborate on projects together. And then I also to engage in the practice of remix. I mean, I don't want to kind of downplay the complexity of making games and what we ask students to do, given yesterday what we saw, all the work which went into making Never Alone. I mean, people have expertise in graphics and design and programming, what are we expecting of 11, 12, or 13-year-olds? So provide starter games. The Scratch community has tons of games which are already been designed. You can't expect somebody in a classroom project to do all the work. It's perfectly fine. 1/3, if not a fourth, of all projects in Scratch are actually remixes. It's part of that particular culture. Let's embrace this in school. It's not cheating if you don't start from a blank sheet. It's part of a cultural practice. So all of this to say, the reason why I think making games, playing games are important because they feed into computational participation. And for me, the point was when I created an analogy, when many cities became unlivable places, designers and planners realized that they actually needed to involve the public in the decision-making process when public spaces are designed. And I think likewise, if we think about the technology as a digital public in which we all live, whether you are on Facebook or whether you're Googling something right now, we're all living in this space, and I think we all need to have a voice in making that a livable, an equitable, and inclusive space for all in order for that to work. Thank you very much.